Hi, I want to tell you a little bit about the problem solving that you need to do for the calorimetry lab, which is also named specific heat capacity and density of an unknown metal. Um, Here you can actually see some data that one of your classmates used in his problem solving. We've got table A and we've got table B. I actually have provided you data. I actually sent that through email, so find that set of data, but I'm going to model the problem solving with this data from a classmate. So problem one asks you to figure out the heat gained by the water and the heat lost by the metal. So for question one, we're setting up two calorimetry equations. So remember that the calorimetry equation allows us to determine how much heat has been gained or was required to heat up a certain mass using a certain heat capacity, a certain difference in temperature. So the first thing we want to calculate is how much heat was gained by the water. Basically in this lab, we measured out 120 milliliters of water and put it into two styrofoam coffee cups, one nestled inside the other, and we took the initial temperature. Then we took a piece of metal, we weighed it, we heated it up in water to 90 degrees, and then we moved that piece of metal into the water. So what happens when you put a piece of hot metal into water? Well, we expect that water to get a little warmer. So everybody measured out 120 mils of water. You may not remember this from the other day, but one thing we said about water is it has a density of 1 gram per mil. So if its density is 1 gram per mil and I have 120 mils, how many grams will that equal? Well, at 1 gram per mil, that would be 120 grams. So that's going to be our mass of water for our first calorimetry equation. Everybody had that much. And of course, the heat capacity of water, you can look that up in the table in the book that you wrote down. And then we want to know the delta T of water. Well, you can see from this student's data that their water started at 26.5 and it increased to 28. So how am I going to get the difference in temperature? Well, I'm going to take 28 minus 26.5, which would be, in this case, 1.5. Now, this is not going to be the temperature you used. You're going to look at the data I gave you in that second table and calculate for yourself that delta T. So if I multiply these together, what I get is 120 times 4.184 times 1.5. I get 753.12 joules. That's how much heat the water absorbed. Once again, when you do this calculation with the data I provided you, you will get a different value. So why did the heat gain water? Well, it gained water because the metal lost that same amount of heat. So we're going to set up a second Q, and this is going to be the heat lost by the metal. And because the water took the heat from the metal and the heat lost the metal, we know that these values will be the same. Why did the water get warmer? Because the metal got cooler. So we can reuse that Q value. And now we're going to get the rest of the data based on the metal. So you can see that this student measured out their piece of metal. So what's going to be our mass in the second one? Well, it's just going to be this first data from the data table. I'm sorry, this first mass from the data table. Now the heat capacity is what we're trying to figure out. That's our variable we're solving for. And so the last thing we need, we've got our Q and our M, is we need our delta T. So let's look at the data from this student. The metal was heated up to 90.5 degrees. And when its temperature had dropped to 28 in the water, it had given up all its heat. That's when the water stopped getting warmer. So we can assume that they had come to equilibrium. So to get my delta T, I'm going to take the 90.5 from the hot water, and I'm going to subtract 28 from that. So 90.5 minus 28 is 62.5. Now, once again, I'm going to keep saying this, sorry. You're not using the exact same data as me. I'm using one of your peers' data. You're going to use the data that I provided you in the data tables that I emailed you. So if I take this and solve for CP, 753.12 divided by 86.73 divided by 62.5, I get that my CP is 0.14. Okay, so that's the answer to question 1. You're going to set up 2 calorimetry equations. The first one with 120 grams and 4.184, and whatever your delta T is, based on the data that I provided you. Then you're going to reuse that Q and set up a second one with the data for the metal. So this will be the heat capacity of the metal. Yours will be different. Question 2 asks us to solve for the density of the metal. So once again, you can see we actually already have the mass of the metal from the prior problem. It was the top entry in the data table, A, right there. So the next thing we're going to need is the volume of our metal. So in this lab, we used water displacement to figure out the volume of the metal. So for this student, he had 31 mils in his graduated cylinder. Once he added the metal, it went up to 38. So how are we going to figure out the volume? Well, it's just the difference in those 2 volumes of water, the water with no metal and then the water with metal. So my volume in this case is going to be 38 minus 31, so 7 mils. And that's what will go on bottom for my volume. You're going to use the data that I provided you to get the same information. So when I take 86.73 divided by 7, I get a density of 12.4 grams per mil. So that is my second data point. Question 3 asks you to determine, or to predict, excuse me, 2 places in the experiment where errors could have been made that would impact your results. So you can either talk to a classmate about that, or you can just be reasonable. Look at the different places in the lab where simple errors could have resulted in bad data. Remember that an experimental error should not be things like, I did the calculations wrong, or I broke something. Experimental error is, when they're asking for that, they're saying, where, if you weren't careful enough in lab, could you have gotten erroneous data or maybe skewed your results in some way? So the last question is, what is your metal? So how are you going to determine that? Well, you will have 2 pieces of data. In this point, our 2 pieces of data are a heat capacity of 0.14 and a density of 12.4. What you're going to do to figure out your metal is you are going to by the way, this is the actual data that I emailed you. So this is what you will use. But you are going to go to Sorry, let me get there. You are going to go to the slides for this unit. And in there, we have two different tables, one of common densities and one of common heat capacities. You actually wrote the common heat capacities in your notes, so you already have those. But I just want to point out these two other slides that will help you out. So here's our slide of common heat capacities. You may recall that in my scenario where I did the problem solving, my heat capacity was 0.14. So are there any metals that are close to that? Well, the closest ones would be lead, which is 0.128. And then the other one that's kind of close would be tin, which is 0.21 joules per gram degree Celsius. And then we're going to go down, that was on slide 24 if you were looking. We're going to go down to slide 30, which has our densities. So here you can see all the different densities. My density was 12.4. So is anything close to that? Well, lead is 11.3. And really nothing else is close to 12. So when you go back to respond to that last question, what you're going to do is you're going to write it in sentence form. I think my metal is, and in this case, you would probably guess lead, right? My heat capacity was 0.14, which is close to lead's 0.128. My density was a little above lead's. And so we had 12.4 grams per mil compared to 11.3 grams per mil. But that was the closest metal. So notice that this is not perfect. I'm not looking for perfection. But what I do want you to do is to mention the data you calculated and the data of the metal that you're comparing it to. So you should be mentioning the heat capacity that you determined in step 1, the density you determined in question 2, and then you should be comparing them to some of the data that we see in those slides when you're making your guess. You're not gonna, if you get the wrong metal, I'm not penalizing you for that. What I need to see is that you can support it with the data you got in the problem. So hopefully that was somewhat helpful, and good luck with the problem solving. If you were out, remember you have the standard 5 days to get it in. Thanks.